Hello, Algebra 2 students. I'm talking about the rules of exponents. And I got it all set up for you to talk about these three things. There are more, but today we're going to settle on these three. The first one is called power of a power. This is where you're taking a number or letter that's already to an exponent. It's already taken to an exponent, and then you're going to square it or cube it or whatever. When you do that, that equals a to the mn. Now, if you're like, well, this is all letters, let me show you what I really mean by this. So if we're going to do an example, a couple examples of just power of a power. If you have x, we'll just use the generic x, taken to the, say, third power, and then I square that. Well, that's going to be x to the 3 times 2, which is 6. The reason why is if you watch closely and think about this, especially if you're a visual learner, x to the third is x times x times x. That's x to the third right there. If you square it, that means you multiply it by itself. That means you have 2 of them. So how many x's do you see? 6. That's why that works the way it does. Every time that works like that. Now this also, you'll also see this like hidden within problems. Like probably one of the most common ways you're going to see this is something like maybe 3x to the second, y to the third, and then maybe that's all taken to the 4th power. Okay, to do something like this, well, that actually equals 3. This 3 actually goes to the 4th power as well. Because if you never see, like I'm 42 years old, and that's actually 42 to the 1st power. So this 3 right here, let's just get rid of that because that's depressing. There we go. So this 3 is actually 3 to the 1st power right there. So this is 3 to the 1 times 4. But if we're actually going to do this, you don't need to write all that out. What you need to do is take 3 times itself 4 times, which winds up being 81. 81. Then it's going to be x to the what power? Blurt it if you know it, people. 8, good job. And then y to the 12. And that's basically the rule of power to a power. Now, the next one I did was power of a product. And that looks like this. Where you have 2 numbers or letters, usually 2 different letters, and they're taken to a power. So if you had that, an example of that, of course, would be something like, kind of like the one I just did almost, like 2xy, and we're going to square that. Well, then you got to get in the habit when you see something like this, you square everything. If it's in parentheses taken to an exponent, you do that to every single thing in there. So it's going to be 2 to the second. What's 2 to the second? 4. And then x, again, it's x to the first, so it's 1 times 2. So this is going to be x to the second, and that is an x, and y to the second. So this is power of a product. It's very similar to this because you're still going to multiply it. If I made this x to the third right here, like 2x to the third y, and squared that, it would just be 4x to the 6th, y to the 2nd. But you know the common mistake people do is they put a 2 here. They don't square the number. You got to make sure that you don't ignore the coefficient. Okay, the final one is called power of a quotient. And I'm just going to go ahead and write this one out. So this is where you have a fraction, say a over b. Let's do that again. A over b. And we're going to take that to the power of n. Okay, n. This actually equals a to the n over b to the n. This is a huge rule here. This happens anytime you square a fraction, say 2/3, or take it to any power, 2/3 squared. You'd be surprised how many people do not know how to do this. This translates into 2 to the second over 3 to the second. That's what these letters mean, people. Okay? And then, of course, you can't leave it like this. You have to simplify it. So 2 to the second would be 4, and 3 to the second would be 9. And you can see what actually is happening here on the side. Although this right here is definitely true, what's also happening here is this is just 2/3 times itself. 2/3 times itself is 4/9. That's power of a quotient. The other thing is you could have negative exponents here. Actually, any of these exponents can be negative. If you did, though, let me show you how to do something like that. If you had anything taken to a negative exponent, like say 7 to the -2 power, for example. Okay? This is important because 7 to the second power, positive second, would be 49. 7 to the -2 power is like this. It's 1 over 7 to the second. So if you've never seen that before, if you have a negative exponent, you put it downstairs in the denominator spot as a positive, and then you work it out. So this actually equals 1 over 49. 1 over 49. You can also have fractional exponents. We're not going to do that today, but that's actually square roots. Like, for example, 49 to the 1/2 power is actually equal to this, which is 7. So if you've never seen that, that's also coming with the fractional exponents. So let's see here. I'm going to set one more of these problems up with a negative exponent, and let's see how you handle this. I'll let you try it here. I'll hit the pause button, and you do the same. So let's say we had 2/3 to the -2 power. All right, go ahead and hit the pause button as I am going to right now. And we are back. Let's see how we do this problem. I'm going to show you the turbo shortcut easy super awesome way to do it. If you have a negative exponent and this fraction is in here like this, taken to a negative exponent, you go like this. Watch it closely. You'll miss it. 3 over 2. I flipped that fraction and changed that to a positive. That is a completely legal way to do this. One more time. Flip the fraction, take the reciprocal of it, change the exponent to a positive, and then you square the top and bottom just like I did over here. So what's going to be on the top? 3 times 3, which is 9, and on the bottom 2 times 2, which is 4. And that, my friends, is the final answer. I will see you tomorrow with more rules of exponents.